In this problem, we're going to find the coordinates of the center, the vertices, the covertices, and the foci for the ellipse with equation 4x squared plus 25y squared minus 16x minus 50y minus 59 equals 0. And then we're going to sketch a graph. So in order to do this, we need to change the equation into standard form. And in standard form, this is what we want the equation to look like. It's written in blue on the top right. We're going to have x minus something squared over denominator plus y minus something squared over denominator equals 1. So the first thing I need to do is I'm going to group my x's together, group my y's together, and we're going to add 59 to both sides to move the 59 to the right. Now, I don't want coefficients in front of the x squared and y squared before I complete the square, so we're going to be taking the 4 out of both the x terms and the 25 out of both the y terms. And now I'm ready to complete the square. So taking half of the 4 from 4x and squaring it is going to give me 4. So I'm going to be adding a 4 into the parentheses, and when I do that, I'm really increasing that left side by 4 times 4, so I'm going to match it with a 4 times 4 on the right. Next, I'm going to be taking half of the 2 from the 2y and squaring it, and that's going to be 1. And when I put a 1 in the parentheses, I'm really increasing that left side by 25 times 1, so I also need to increase the right side by 25 times 1 to match it. Now, when I factor, we're going to get 4 times x minus 2 squared plus 25 times y minus 1 squared, and all that stuff on the right adds up to 100. Now, I really want the equation to say equals 1, so I'm going to divide everything through by 100. And when I reduce the fractions, this is going to give me x minus 2 squared over 25 plus y minus 1 squared over 4 is equal to 1. So that's my equation in standard form. So now I can tell that the center of the ellipse is going to be 2 from the x minus 2, 1 from the y minus 1. So let's say there's my center. Now to find the vertices, the first denominator, which is the largest, is a 25. So that means I'm going to be going right and left 5 spaces to find the vertices. So there's one vertex, and let's say there's the other vertex. And that's a horizontal direction because the 25 is under the x. So those points are 5 spaces to the right and left of the center, which was 2, 1. So that will give me the points 7, 1 and negative 3, 1. Now going back up to my equation, I can see from the other denominator, which is the 4, the square root of 4 is 2, so this means I'm going to be going up 2 and down 2 to find the covertices. And let's finish drawing the ellipse here. Of course, you'll make yours actually go through the points. And the covertices, since those were 2 spaces above and below the center, they're going to be at 2, 3, and 2, negative 1. Now I need to find the foci, so we're going to use the equation a squared minus b squared equals c squared. I already know that a is 5, that was the distance from the center to each vertex, and b is 2, that's really the distance from the center to each covertex. So when I plug those in the equation, I get 25 minus 4 is c squared, or c squared is 21. And that will mean that c is the square root of 21. So my foci are going to run along the major axis with all the other things like the vertex and the center. So they're going to be the square root of 21 spaces to the right and left of the center, or 2 times the square root, 2 plus the square root of 21, comma 1, and 2 minus the square root of 21, comma 1.